today we're looking at virtual machine movement and Hyper-V Replica. So one of the biggest advantages of our enterprise virtualization that we've been talking about is the fact that we want to maintain uptime. Okay, when we say uptime, we're talking about the services. Okay, so obviously, if we're talking about, let's say, a web server, and we want clients to be able to access our web server to buy our sports shoes or buy the lollies for the Earthy's confectionery, it doesn't matter. But just think of that. Okay, so think of something like eBay. If that was offline, you would imagine that that company would be missing out on, thousands, if not hundreds of thousands, if not millions of dollars of sales. I'm not saying every company is like that, but I'm just saying if that service, which is critical, mission critical, is offline, it's got a big impact on the actual company's bottom line. So with that in mind, what we're concentrating here today, as well as in most of virtualization, is the idea of maintaining uptime. How can we keep services that are mission critical up and running more often than not? There's obviously lots of things we can do, including redundancies, including backups, including clustering of the network load balancing with Windows servers, or even load balancing between services like Microsoft Oracle. But what we're going to concentrate on is obviously what we can do at the virtualization level in this subject. So today we're looking at virtual machine movement and Hyper-V replicas. Okay, so we'll get straight into it, and we'll always relate back to uptime. That's a critical thing here. So today we're going to look at providing high availability and redundancy for virtualization. We'll be implementing virtual machine movement as well as the Microsoft Hyper-V replica. So let's get started with providing high availability. So this is all about that up I was talking about. Okay, server downtime is unavoidable. There's no way of avoiding it 100%. That's why even those numbers on the bottom right are referring to 99% to 99.999%. There's no such thing as 100%. Okay, and the reasons why is that a little bit beyond the actual faults and failures that we are not expecting. We are actually expecting routine maintenance, such as application of service pack patches and everything else. Okay, so we know that if we were applying a service pack to the actual virtual machine where the service is running, then potentially that's going to cause some downtime. But obviously, there's always things we can do. It's a bit like how long is a piece of string, if you've ever heard that saying. There's always something you can do, but it's a matter of your budget, balancing that with your budget, and balancing it with budget and what you can afford to do. So servers are not always available. Okay, obviously server downtime is unavoidable. It doesn't matter, even if you do everything that's possible, there's always going to be some level of server downtime. Software and hardware maintenance or upgrades. So if we're talking about that as a reason for downtime, software or hardware maintenance or upgrade, they're what we called expected. They're all planned, aren't they? If you're going to upgrade or maintain the software or hardware, it's planned. It's not just all of a sudden out of nowhere an upgrade happens without your knowledge. Okay, these things are planned downtime or planned outages. So they're we treat them a little bit differently to how we treat unplanned outages. Okay, so again, the application operating system updates comes in the form in that category as well as planned outages or planned downtime. Okay, so the reason why I'm stressing this so much is because when it's planned, it's a lot easier to handle than when it's unplanned. Okay, unplanned things include component failure, power outages, natural disasters, basically anything that you cannot foresee happening ahead of schedule. Okay, so you might say power outages. Yeah, well, there's different types of power outages. It could be that someone crashed into the telegraph pole near your, the power box near your house, and that puts your whole street out. But there'll be other types of power outages which are like they're doing maintenance on the street and power will be out for 2 hours between this time and that time. So even with power outages, there are planned and unplanned things. So you have to think of those two things. Okay, so plan means it's something we know about ahead of schedule, which always means we can have a lot more options up our sleeves than if it was something that's unplanned. Okay, critical services must be constantly available. Like I said, if your company relies on this website to do business, and that's the only way you're doing business at the moment, just think of all those shops in Melbourne right now. They can't open their doors physically, but they can still trade online. So if they weren't trading online, they wouldn't be making any money as well. So they'll be depending on these critical services. So obviously, these critical services are running in virtual machines. When fails or unavailable, it must be serviced elsewhere. So, for example, if the virtual machines fail or become unavailable, how are the customers going to get the service? So you have to have another way. Goal of high availability. So high availability, like I said, is all about uptime, makes services available, and even when failures occur. Okay, and obviously, if we look at the table on the right, if you look at the percentage availability, so 99% availability, that sounds pretty good actually. 99% of the time it's available. But if you actually look at that, that actually equates to 3.5 days of downtime per year. Okay, if that's 3.5 days of your business not being able to make money during a year, then that's possibly too much downtime. 99.9, 8 hours, 8.8 hours, 99.99, 53 minutes, and the ideal, or industry ideal at least, the 5 nines, 5.3 minutes per year. Okay, so that's what most of the IT industry is trying to get to, but the reality is it's probably somewhere between the 99% and the 5 nines. Obviously, the better we have, the better it is for the business, and it could also be part of the service level agreement if you've ever heard of that term. So there might be if you're doing something if you're hosting services for another company, then you need to sort of promise or contract for a availability, which in this case you need to make sure you meet those, or else you may not be able to. You'll be breaking the contract. So that's what a service level agreement is. So if you've provisioned, or in your service level agreement, you've said that we will give you the 5 nines, you end up giving them the 4 nines, then that you're obviously contravening the service level agreement. So just make sure that you're very clear about what is able to be delivered, rather than over promising and under delivering. Go the other way. Under promise and over deliver. But don't forget, if you under promise, you might not be you might not even win the contract if you can't promise a certain level of performance or availability. So if we talk about the things we can do at the different levels, like I said, we're going to concentrate on what we can do at the virtualization level. But we all know that if there's hardware failures, what we can so if there's hardware failures, the Windows hardware error architecture, reliability, availability, and serviceability. What can we do with physical hardware failures? Physical server failures. Then we have live migration for planned downtimes, and failover clustering for unplanned downtime. So we're talking about more about what these things can do in the later slides, but live migration and failover clustering. All right. What about I/O redundancy? So like this is what we're talking about with, just because the virtual machines are running, the Hyper-V is running, but if the network cable is unplugged from the Hyper-V server that connects you to the actual production network, or what we call the production network, then it means that the clients not be able to access those services anyway. So that's not just a network card. It's also if we're talking about shared storage and we're not able to access the storage, if we're talking about other input-output systems and we're not able to actually interact with those systems, then it makes that service or that virtual machine or whatever it is as good as offline or down. So there's network load balancing and NIC teaming. So that's a Windows thing. So network load balancing allows us to actually send traffic to many networks cards, and that could be many servers. NIC teaming, we know from previous lessons where we use multiple network cards to work as a team, meaning if one is actually disconnected, the other one still can provide that connectivity. Multi-path IOs, so obviously, as the name suggests, more than one path to access the storage, as well as the multi-channel SMB, which is similar, which is multiple channels to access the SMB share. At this application service failover, so there's some services which are cluster aware, and there's some services which are not cluster aware. So for non-cluster aware apps, Hyper-V app monitoring will actually detect whether this application is up or running or not, and then can perform an action. And we'll talk more about this in relation to failover clustering a little bit later. There's also virtual machine guest cluster, which allows us to use the iSCSI fiber channel and VHDX sharing, which basically means we can have multiple virtual machines running from the same set of files, if you like. So, and that's something we won't talk about too much in this subject. It's something that is possible. There's also virtual machine guest teaming with the single root IO network interface cards. And then there's this disaster recovery, where we talk about Hyper-V replicas, which is for asynchronous replication. There's also CSV, cluster shared volume integration with storage arrays for synchronous replication. So these are some of the things we can do at the virtualization level, okay, with our Hyper-Vs, with our virtualization infrastructure that can provide better uptime, more availability. So let's talk about virtual machine movement, okay? So as the name suggests, moving virtual machines. What are we moving them from? We're usually moving them from one Hyper-V or one host to another host, or we're moving the storage from one storage to another storage. So that's what we're talking about when we're talking about movement. Why would there be a reason for this movement? Can any of you guys think of any reasons for moving a virtual machine from one host to another host? Have a go, guys. Why would you want to move a virtual machine off a host or Hyper-V host? Yeah, exactly right. So maintenance, yep. So basically, if the host, for example, the Hyper-V machine needs to upgrade the hardware, let's say we need to put more RAM in or something like that, we might have to turn it off to actually add that RAM. If the actual physical host is off, then the virtual machine will be off as well. So we might want to move it off that physical host onto another physical host before we do that upgrading of memory. Yeah, similar to that, Zach mentioned maintenance. Yeah, maintenance include that hardware maintenance, but it could be also software maintenance like application patching. We all know that when we update our Windows Server or Windows our Windows operating system, often there's a restart, and obviously whilst restarting, the virtual machines can't be running. Host failures, yes. If that host where it was running is actually off, then we probably should move it to another host so we can get it up and running again very quickly. Moving locations of server. Ayrton, do you mean moving the location, physical location from site to site? Is that what you meaning there, or do you mean something else?
Well, I suppose yes, but also if you're looking at moving, say, your company from one location to another, that you'd be migrating all your resources across.
Yeah, absolutely. Yeah, that's another reason. Definitely, you wouldn't want to go offline for very long times if you're just moving location. Load balancing, Matthew says, load balancing. I'm thinking he's not. Yeah, he said in the next line. He's not thinking of load balancing the service, but he's thinking of load balancing the host, meaning that if the host, we had multiple hosts and one was struggling with the amount of work it has to do, like it's too busy, it's not enough RAM, not enough CPU, or something else, then there's no point keeping critical virtual machines on there where they can't get enough resources. So we might want to move them to another host. So they're all very good reasons. Yeah. So let's see, hacking threats. Well, when you move a virtual machine from one host to another host, you don't change the network identity of that virtual machine. So if the hacker is hacking the virtual machine, then it will continue to hack the virtual machine if that's all you do, Raymond. Okay. So if you're moving it to actually isolate it from the physical network, then that's a different story. But if you're just moving it while it's being hacked, it's not going to really stop the hacking threat. Yeah, like moving the one brain to another, and I'm not sure if that's possible, but I'll take your word for it. All right. So they're all very good reasons for why we want to move the virtual machine. Okay, so good. You guys are on track. So virtual machine moving options that we can do with Hyper-V. Okay, so it's we have cold migration, and there's live migration. Okay, so cold migration is basically everything's off. You move the where the virtual machine is, you turn it off. You move it to a different host, you turn it back on. Bit like how you guys might have your virtual machines on a portable hard drive. You shut it down on one PC because it's not working properly. You move your your portable hard drive to another computer. You log in, you turn it on, and you open it up, and you turn it on. That's fine. That's one of that's one way to migrate it. But you can see that there's going to be downtime in that situation, isn't there? Okay. Oops. There's going to be downtime. So as opposed to live migration, where the idea is with live migration, there's zero effective downtime as far as the user is concerned. Okay, so we'll talk more about that in a second. So first of all, there's virtual machine and storage migration. So we can move just where the virtual machine is being executed, as in which host it's running on. Or we could leave the virtual machine on the host where it's running, but just move where the virtual hard disks and other files are stored. So that's storage migration. Or we can move both. Or we can move one or the other or both. So that's possible, and the way we can do it is that quick migration, which actually requires the failover clustering. So that's a little bit different to what I said about the cold migration, but the quick migration is automatic, uses that failover clustering. But again, unlike the live migration, there is some downtime, but all that is happening behind the scenes automatically for you. So if it happens at 3 a.m. your time, but maybe like prime time shopping time overseas, it's going to do that behind the scenes automatically for you. And there will be downtime, but it will be, even if it's 15 minutes downtime, it would be better than you having to manually do something. And we'll see where things are applied in the future slides when we use one over other. So live migration requires only network connectivity. It's improved performance in Server 2012 R2 and obviously 16. So live migration, what happens is that the virtual machine is running on, let's say, Hyper-V1. It continues to run on Hyper-V1, but you're going to transfer the execution to Hyper-V2. So what happens is you copy all the migration. So the next slide explains a little bit better. You copy all of that virtual machine to Hyper-V2, but Hyper-V1 virtual machine continues to operate. And then when they replicate between the two Hyper-Vs, the changes, and it's updated on Hyper-V2, and it gets to a point where they're pretty much exactly the same, and they just switch over. And what happens effectively for a user is they don't notice it switches over. So if we in our labs we'll do a ping test, and you'll see that you'll miss one ping packet, which effectively, if someone's doing online shopping, missing one ping packet is not going to affect their experience dramatically. There's also Hyper-V Replica. So this is a little bit different to the quick cold or live migration, in the sense that Hyper-V Replica is all about replicating the virtual machines from one site to another site normally. In our labs, we're going to do it from one Hyper-V to another Hyper-V on the same site, but that's because that's just to demonstrate the replica. But realistically, Hyper-V Replica is replication between sites. Okay, key thing, between sites. Because you can have this quick migration, long migration, all that, if you have problems with individual hosts. But the problem is, what if the problem is not just the individual host? What if the problem is the whole site? What if there's a car just crashed into the junction box on your street unexpectedly? What if it sets fire to it and your whole site loses connectivity as well as power? Then how are you going to continue to operate? So Hyper-V Replica, its intention is to replicate itself to another site, and this other site doesn't even have to be your site. So there's actually companies out there, like hosting companies, which are selling products which is a virtual second site. What does that mean? It means that you can actually host your virtual machines on your site as much as you like, but you pay this for this space that's not actually turned on, so it's not that expensive. You pay for this space, this IOs, and you pay for this second site. So what happens is that you are replicating to this hosting company as a second site, and then if your site something goes wrong, it actually switches over to that second site, and your services continue to operate. So it says asynchronous. So I think Matthew raised his hand for a second there. Did you?
I did. I was just going to say that's a little dramatic, but in another retrospect with Replica, would this also mean, so if I'm going to try and say if the Adelaide site went down and we decided to use the Elizabeth site, does that technically mean as well the configurations have to stay the exact same on either sides? Have to be, say if they were on VLANs, you'd have to have the same VLANs at the Adelaide site and the Elizabeth site.
You would have to have the same switches, virtual switches, but the IP addressing doesn't have to be the same. You'll see that some of the things we'll talk about in the settings, there's a IP address pool for when you're switching sites. So obviously, so they don't have to stay the same. But obviously, if you did have that software-defined networking, then that wouldn't even be an issue. Okay.
The other thing I'm thinking though is, say if it was a public service, i.e. a web server, and it had a particular IP address and a particular port number, would this still become an issue if it was on a secondary site?
Depends how you set it up, because obviously if you directly connected to the internet, then your IP address will be different because you have a public IP address. But if you're doing port forwarding or acceleration, as they call it, then you'll be a address mapping between your public and your private, and you could also use dynamic DNS to change that IP address quickly anyway.
Yeah, gotcha. No, I just thought I'd ask that.
Yeah, no worries. But that's that's something that's sort of looking at the big picture. Definitely good thinking. But obviously, if we're talking about this, we're talking about purely from the virtualization aspect of it. Okay. All right. So getting back to Hyper-V Replica, it says it's asynchronous. When you see a word that says "a" in front of it, it means not, basically. Asynchronously replicates means not synchronously replicates the virtual machine. What does that mean? It means that what happens on the VM here, on site 1, is not going to be exactly replicated in that blink of time on site B. So site A might be 10 things happen, but behind the scenes maybe only one thing has replicated. So the trick here is that hopefully all those changes will replicate eventually, but it's not doing it in that point in time. And that's great. That's not great, but it's great if you have a slow link. Because if you have a slow link between your two sites, then you could, if you had to actually wait for it to be synchronous replication, your servers wouldn't be able to do much, as far as it will have to sit there and wait for confirmation that's finished writing before it can continue to do the next task, which you can imagine could dramatically reflect badly on your performance. But the downside of asynchronous replication, the upside is that it can accommodate slower links, but the downside is that your first site and your second site, the virtual machines may be different. How different? Hopefully not too different, but it may be different. So you might lose some differences if you switch over. We can configure the replication frequency or extend the replication, and we can actually create additional snapshots to revert to, so that we can, knowing that it's not going to be exactly the same, we could have these extras, configure the replication frequency as well as snapshots to actually address that a little bit. We could also, another way of moving virtual machines, like I said, the cold migration, is exporting and importing virtual machines. So exporting while a virtual machine is running, we can import the virtual machine without a prior export as well. So that's another way. But obviously, that import and exporting may be done locally on the same site or to different sites or to even different companies. So let's look at how storage migration works. Okay, so when we're talking about storage migration, that means we're migrating or moving the storage, the virtual hard disks. So here's the Hyper-V server, here's the virtual machine, and obviously the virtual machine, as is functioning, needs to read and write to the virtual hard disk, like the hard drives, and it uses the virtual hard disk stack to read and write. So you can see you're seeing this dot bouncing up and down. That's basically the reading and writing. Okay, so no problems. This is working normally. While it's running, it's reading and writing to and from the virtual hard disks. And that virtual hard disk could be somewhere on the network, like we know, with that shared storage or network storage idea. All right, so virtual hard disk needs to be migrated to a destination storage. So we're moving, let's say we're moving SANs. This old SAN is filling up. We want to move our virtual machines to a new SAN. So we could use the storage migration to do this. So this is storage live migration, if you like, because the virtual machines are actually still working. So it's bouncing up and down, you can see here, but that's because it's still reading and writing. But then the virtual hard disk is being copied to the new location. So once actually the virtual hard disk is being copied, then you have mirrored writes. Okay, mirrored write. So basically, whatever's been written here, it's also been written there. So basically, we're trying to get them to be pretty much exactly the same. And depending on how busy your actual virtual machine is, this could be very quick or could be lengthy to get them exactly the same. Just imagine a virtual machine that's constantly changing and it's being accessed by many users, and they're doing many things. That will take a lot longer to synchronize or get to the exact same state than a server that's not doing much, not being accessed by many users at all. So that will be achieved a lot quicker. But once it's actually achieved, it just simply switches over. So it switches from this copy of the virtual hard disk on SAN 1 to this virtual hard disk on SAN 2. And basically, the virtual machine never went offline. It's still using the virtual hard disk stack, but it just now is pointing to another location rather than the first location. And you have two copies. And then the first one gets deleted, and now you've migrated. And this compares with the idea of storage vMotion. So a live migration is called vMotion VMware. It's similar. And this storage migration is called storage vMotion. So the virtual machine is running and uninterrupted. Key thing, uninterrupted. No downtime. No effective downtime, should I say. So how do we do this? Through a wizard. It's called a move wizard. We can use the moving virtual machine or storage while the virtual machine is running. We can live migrate or storage migration. They're both live in the sense that the virtual machines don't go offline. We can also use the PowerShell commandlets. Storage migration is enabled by default. with two at the same time. So obviously you don't want to move too many at the same time, because all of this is bandwidth or throughput sensitive. If you have more things going on, it just means it takes way longer for that synchronization, or that how we were doing that mirror writes, to be getting to that exact same state. A live migration must be enabled before you can live migrate, okay? But the storage migration is already enabled by default. All virtual machine data can be moved to the same location, or you can specify locations for each data item, or you can move the virtual hard disk only. So don't forget, when we're talking about virtual machine and the files of a virtual machine, there's the virtual hard disk file, which is the most obvious one. But there's also the configuration file. There's also the virtual memory file. There's also snapshot files. There's a whole bunch of files as well. So normally we would choose to the same location. If you wanted to, for some reason, you could have it on different locations. Virtual, like I said, virtual machine data items include the virtual hard disk, the configuration, the checkpoints or snapshots, and the smart paging, which is basically your virtual memory. You can move only the virtual machine, or also include the data items as well. And that compares to vMotion in VMware. All right, let's have a look at live migration. So live migration, the easiest way to do live migration is have a shared storage. So basically what we've been talking about, that instead of the virtual machines being stored on the physical Hyper-V servers themselves locally, they're stored on a SAN or a shared storage. And that could be fiber channel over Ethernet, iSCSI, or SMB3. Okay, no problem. So this example here is where that's happening. Okay, so the reason for this is that it's actually really quick to move virtual machines if they're stored on a shared storage, because you're not moving the storage. So live migration is all about moving from one Hyper-V to another Hyper-V server. But if the storage is on a shared storage, we don't have to move the virtual hard disk, which might be hundreds of gigs in size. What we are really moving is just the content of the virtual machine's memory. Okay, so it's running on Hyper-V 1. So it's using the memory from Hyper-V 1. It's using the CPU from the Hyper-V 1. And that's what's actually on Hyper-V 1. But we want to move it to Hyper-V 2. So what we need to do is copy that memory items to Hyper-V 2. So virtual machine memory is moved in iterations, in sort of turns or versions or lots. There are different ways of saying iterations. So it could be version 1, version 2, version 3. So many different lots. The source is active. So the source is active and stays active until they reach a point where they're basically the same. Modified memory pages are sent after the initial copy, and this runs over and over again until they achieve this state where they're basically the same, and then the final iteration takes less than a TCP timeout, and that's why you'll see that you'll miss only one ping packet probably. So the new MAC address is sent to the network switches, and then it's updated, and basically all the clients are accessing the machine on the second Hyper-V server. So let's have a look at this. So this is the memory. This is the configuration. This is the current state. So what happens initially is that you copy all of it over to the Hyper-V machine. Okay, and this, relatively speaking, is not that much, because if you define a virtual machine with 10 gigs, then that's really just 10 gigs of memory that's being moved. If you define a virtual machine 1 gig, that's really 1 gig of memory that's being moved across from Hyper-V 1 to Hyper-V 2 through a network. So let's have a look at that again. So initially everything's copied, all the green, but you notice there's a red on the Hyper-V 1, and that's because that's been changed while we're doing this. And in the second iteration, moving those changes, and we get to a point where they're the same. Then we move the state. The state basically transfers the operations to that second Hyper-V. Okay, prerequisites of Hyper-V Replica. You need server 2012 or later, and you need at least 2 servers, and they're usually on a different site. Even though, I want to emphasize, even though we're in our labs, we're doing it on the same site, on the same network, they're usually on different sites. They become less useful if they're on the same site. The most important uses is where they're on different sites. So other things we need to have is sufficient storage to host the virtual machines. Obviously, if we don't have enough space to store the virtual machines, we can't really replicate, can we? There needs to be connectivity between the primary and replica sites. And like I said, the primary and replica sites don't even have to be, you don't have to own both sites. Okay, you could just replicate to a hosting company if you wanted to. The firewall, obviously any communication for a network must be allowed for a firewall. So Hyper-V Replica, HTTP, and HTTPS must be allowed. So yeah, as you can tell, it's actually porting, if you've ever heard of that term, this through the HTTP and HTTPS protocols, which is typically used for web traffic, not replication traffic. But you know as well as I do, normally this type of traffic is allowed through firewalls. The X509v3 certificate for mutual authentication. So obviously we don't want to replicate to someone we don't trust. And how do we know that that is the right server? We have to mutually authenticate. So we don't want to receive replicate from someone we don't trust either. So mutual authentication proves who the other party is. It's not just a one-way authentication. If certificate authentication is used, we use that X509v3 certificate. Otherwise, the Hyper-V host must be in the same Active Directory domain services domain, which again gives you, Forest, which gives you that trust, level of trust. Okay, so overview of Hyper-V Replica. Yeah, let's actually look at the picture to see how it works. All right, so basically you have primary site and you have the secondary site. And on the primary site, you have a cluster shared volume block storage. Okay. On the secondary site, you have a SMB shared storage. Okay, so BOM uses the shared storage. So you got these blue virtual machines on the primary site. They're running. They're working fine. And what happens is that they're replicated. As the name suggests, the virtual machine files, virtual hard disks, are replicated. That initial replication is big blobs, if you like, because there's a lot of data to replicate. So, but then you have these little balls because they're actually changes that are being replicated. And for some reason, that primary side goes offline. That could be even a planned offline or unplanned offline due to some emergencies. Then these virtual machines takes over the services and becomes available, and your systems, your services will become available. Will be still up and running. So obviously there is going to be some downtime. So first of all, this primary site is running, the virtual machines are running here, and you replicate it, but the downtime comes where especially if it's an unplanned outage, you have to sort of be aware, or you have to know that this primary site is out before you can take over. Okay, so that time it takes for it to know that it's out. How does it know it's out? Well, don't forget you're getting all these replications normal, don't you? All these little replications happening on a regular times. If that stops coming, and it stops coming for a while, and you missed so many replication, then you can assume that's offline. Okay, because they're dead. How do you confirm they're dead? You can't really ping it to say, yeah, tell me if you're dead. So when there's replications stop coming, then after a while we can assume that's offline, and these ones will take over. So I think our friend Matthew was talking about what happens when you move the virtual machine from the primary to the replica. What about the IP addressing? So replication is enabled per virtual machines. So it's not enabled on all virtual machines. You have to decide which virtual machines are high value, or which virtual machines are the ones that are mission critical. So you enable it on those. The less, the better. Obviously, if you replicate unnecessary services, for example, if there's a virtual machine with DHCP, that seems odd to replicate that one. Whereas if you've got a virtual machine which has actually got your Oracle database for your ordering system, it probably is more advisable that you replicate that one rather than the HCP server. Okay, so we enable replicas. So enable replication, there's a wizard, and we actually specify the replica server, the connection parameters, choose the replication of the VHDs, choose the frequency, add additional recovery points, so that it's like they're like snapshots really, and then choose how you're going to do that initial replication method. If you remember, I mentioned that initial replication is big because we're replicating. We're not just transferring the running of the virtual machine from one host to another live migration. We're actually moving the whole virtual machine files, not moving it, but making a copy of it. And what we're doing is we're doing it through a slow WAN link if it's on different sites. So that is going to be big amount of data, slow WAN link. So that's not a good formula. So what we could do at that initial replication method is we can choose to replicate to a portable hard drive or external media or whatever you want to have. We can certainly replicate it over the WAN, no problems there, but we can also choose to replicate it to an external hard drive, for example, and we can physically drive it to the second site. It might take us half an hour. Then we plug it into the second site and we see the replication from that external hard drive. And you can imagine that would be possibly a lot faster if you had to replicate 10 virtual machines, each one with 100 gigs data over a slow WAN link. So you might take you 30 minutes to drive there, but the overall time might be faster than that 30 minutes. There's also some failover settings. Okay, so one of the biggest problems that I think Matthew was talking about is that your primary site has, let's say in this diagram, 10.22.100.18, but your replica site has 192.168.15.10. They're totally different IP address ranges. So you can't expect the virtual machines with static IP addresses to actually switch over and still continue to work without that software-defined networking. So what we can do is we can pre-configure IP address for replica virtual machines. So what does that mean? It means if once it gets replicated and once the replicas get activated, as in brought online, then it will start using these other IP addresses because it's on this site. But that requires that integration services, and it should be configured on both the primary and secondary or replica servers. So the virtual machine gets, so let's have a look at what's happening there. So the virtual machine is running on the primary site. It's been replicated on the replica site. And then for some reason, the primary site needs to go offline. If that's planned, that's no worries. We can do a planned failover. And when we do a planned failover, we just basically go switch the operations of the virtual machine from primary to replica. There is downtime, okay? There's no downtime even for planned failover because you're really turning on the virtual machines at the replica site so that even that turning on period of time is the downtime. It could also be unplanned. So for example, primary site explodes, total site explosion. So we don't know of this. We weren't warned of this. So the replica has to sense that that's gone by the missed replications, and then it will fail over. Yeah, that's very interesting. I was just trying to emphasize the fact that there's no way of recovering. Okay, so you have to fail over. So there's also a way of actually seeing the replication health. So obviously, when we do the lab, you'll see that you can actually go in and look at that. So there's different states. There's the normal, warning, and critical. So normal means less than 20% of the replication cycles are missed. The last synchronization point was less than an hour ago, and the average latency is less than the configured limits. Well, that's good, that's fine. But where it becomes warning if the missed replication cycles is more than 20%. And more than an hour has since the last sent replica, initial replication, or the initial replication hasn't been completed, or if it's been failed over, but the reverse replication is not configured or not working. Primary virtual machine replication is paused, then that gives you a warning. There's also critical is replica is paused on the replica virtual machine or primary server unable to send the replica data. So these are the different error levels. So what we can do in our labs is we can test failover. When we do a test failover, it's a non-disruptive testing with zero downtime, meaning we don't actually turn off the primary virtual machine at the primary site. We basically make the test failure basically creates a new virtual machine at the replica site from the checkpoint, but it's turned off and not connected. Then we can stop the test failover. So that's just making sure all the infrastructure is there and works. There's a planned failover, like I said, if we know that our first primary site is going to go offline next Friday because there's going to be maintenance on the street where they're going to dig up some trees and that will disrupt our network connectivity. Then if we know that's happening next Friday, we could plan for failover on Thursday night. So it's planned, meaning we're expecting it. So we initiate this at the primary virtual machine, which is turned off first. We turn it off. Sends the data that has not been replicated. So obviously we wait for it to be the replication to catch up. Then we fail over to the replica server, which means we start the replica virtual machine and we configure reverse replication after the primary site has been restored. What does that mean, reverse replication? So if it's on site B, the virtual machines are being accessed by clients. That's the whole point, and so it's been changed. But these changes needs to be replicated back to site A once it actually comes online before we can actually put it back on site A. Then there's failover. So if planned failover is something we know about ahead of schedule, failover is where we have no idea it's going to happen. It just happens one day. Something happens, causes failover. So like it could be that there's an accident, someone crashed into the power mains, no power, for example. So it's initiated at a replica virtual machine. So it's initiated when the primary virtual machine has failed, turned off, or is unavailable. There could be data loss because the differences between where the primary virtual machine was at and where the replica virtual machine is at might be different because the replication has not all gone through. Okay, so with the failover, we can also reverse the replication after the primary site has been recovered. And other replication-related actions include we can pause and resume replication. We can view the replication health. We can extend the replication. We can remove recovery points, which are basically snapshots. Snapshots go out of date after a while. And we can also remove replication if that server is no longer need to be protected. Replica Resynchronization, where normal replication is interrupted. Change tracking issues on the primary server. So when replication process is interrupted, let's say it was cut, and there's some change tracking issues on the primary server, or there's replication issues with the tracking log, or there's problems linking the virtual hard disk with the parent, or someone's reverted the snapshot is restored from backup or from checkpoint. Reverse replication after, or it's a reverse replication after failover. So basically, with the replication resynchronization, it needs to resync. And we configure on the primary virtual machine, it could be manual, automatic, or during a scheduled time. But if it's going to take more than 6 hours to resync, it does a full initial replication again. So basically, if it's going to take that long, you might as well do a full initial replication, which means we don't miss anything.